Hey, it's Bob Duffy from Intel here with another episode of TechCraft, and we're doing something a little bit different. We're going to do a tutorial this time. Usually my videos are a walkthrough of how to actually operate and run something like Stable Diffusion, but this time we're going to show you how to do an installation because usually I get that in the comments. So like, yeah, that's pretty cool, but how'd you install that application? So we're going to install ComfyUI on a system that has an Intel Arc GPU, and we're going to start with this guy. That's right. We're going to do Stable Diffusion, ComfyUI, on an MSI Claw. Maybe you didn't know you could do Stable Diffusion and image generation on an MSI Claw, but it is a PC. It's an handheld gaming PC, and it's got 8 gigs of VRAM for the GPU. And then what we'll do is we'll step it up from here. We'll go up to the 16 VRAM system, which would be the MSI Prestige, also Intel Core Ultra, and then we'll do it on the Arc A770. In each way, we'll kind of step it up in terms of what we're doing with ComfyUI and Stable Diffusion. So hopefully you'll learn a few things along the way. All right, so it's going to be a lot of fun. Let's dive in and check it out. Okay, we're ready to go, and here we are on the MSI Claw. Yes, a handheld gaming system. We are going to install ComfyUI on this, so if you can do it on this, you can do it on any system that you have an Intel Arc GPU. So you can see here, I've got my Intel Arc graphics here, and down below you can see I've got roughly 8 gigs of memory, and that's because this is a 16 gig system. So on an Intel Core Ultra system, it's going to split that memory, half for the CPU and the other half for the NPU or GPU. So we're working with about 8 gigs of VRAM. But we want to get into the installation. So I've got this set up here where on the right is the install instructions. And before we dive in, I just want to give you an overview of these instructions. And then once we get into this, we'll be following these instructions on the right and then doing the installation in Windows over here on the left. But to get to these instructions, follow the link to the Insider's Discord. You'll get right here. And it's pretty simple. It may look daunting, but really all there is are some prerequisites. I'm not going to go through doing this stuff because if you've done anything with any GitHub project, you would have already done this. So you're going to install Git for Windows. Make sure that you have Python installed. 3.10.6 is what we recommend. And then the last one here, if you are doing this for a discrete GPU, we do recommend that you disable your iGPU. So just go into the device manager, disable the iGPU, and you'll be running off your graphics. In this instance, we are doing it on integrated graphics, so nothing to disable there. And then the installation is broken into 2 parts. One, it's really just getting the files. So you're going to get the repo from ComfyUI. You're going to clone that, and then you're going to download one of these 2 files for the requirements.txt installation. And then you've got 2 choices when you actually do the install is you could either do it through your command window or you can do it through Anaconda. And we'll actually do Anaconda because maybe some of you haven't seen Anaconda, so we'll do it through there. But really they're the same instructions and there are only really 3 parts to this is 1, set up your virtual environment. 2, switch to the directory where you downloaded your ComfyUI install. And thirdly, just run that requirements.txt file that you downloaded. And that's it. That's all you need to do in order to get ComfyUI running on an Intel Arc GPU. Now we're going to do it through Anaconda. So I've provided a link for Anaconda. So you're going to get to a page like this, and it will ask for your email. And then what you'll get is something that looks like this sent to you, which will allow you to download Anaconda and just follow the instructions in order to get that downloaded. So that's it. That's an overview of the installation process. Let's dive in and give ComfyUI a try. Okay, we are ready to go. So let's follow our instructions here. Let's launch a CMD window at the location I want Comfy installed. So I've got a folder here called Video Comfy. So I'm going to do it here, and I'm just going to hit CMD right in that address bar, and that brings up a command window direct from here. So let me move this over to the left and keep my instructions over here on the right. All right, so what I want to do now is clone ComfyUI directly there. So let me go ahead and paste that on this side. So let's git clone ComfyUI. So that's going to go ahead and create that in that directory. Now, the next thing I want to do is download the appropriate requirements document. I can either use the requirements IPEX Ultra if I've got an Intel Core Ultra, or if I got a discrete GPU, I can use the requirements-IPEX file. So since this is the requirements IPEX Ultra, I can go ahead and click on that one. All right, so let me go ahead and move that file from my downloads, which I believe I had already downloaded it. It's right there. So I'm going to copy it, go back over here, go in my ComfyUI directory, and I'm going to paste it. So there it is. We are done there. Okay, so now I can do either method 1 or method 2. So I can either continue through my command window here, or I can try Anaconda. And in this demo, we're going to try Anaconda here on our MSI Claw. So install Anaconda for Windows 64-bit. That I've already done. And then launch Anaconda. So I'm going to go ahead, start, type in Anaconda, and run as administrator. Yes, there we go. And I'm going to move that window over here as well. Now, enter Conda create Gen AI Python. And then I'm going to change the name here because I've already done this. So I'm going to hit boom, and I'm going to change the name to video demo. Video demo. Right, so that's my environment, video demo, and Python 3.10. So I hit enter there. Let me do it again. Get rid of enter. Well, let me get rid of this whole thing. Let me just copy this right there. That's all I need. Now we got it. Okay. That's going to install all the packages for my virtual environment. And I hit yes, I do want that done. And that's going to finish that off there. Okay. So the next thing I want to do is activate my environment. Now I'm not going to activate Gen AI. I'm going to activate video demo. So Conda activate video demo. All right, now I can see that it changed from base to video demo. So I am now in my video demo environment. Now put in the path to my ComfyUI folder here. So I'm going to change directory and go to that path that I had before. That was this one here. That is ComfyUI. Got that. Let me paste that in. That looks good. Hit enter. I am now in that directory. So now I can go ahead and put in the command for that requirements file. And this is the one that I use. So I can do the pip install requirements IPEX ultra.txt. And this is the key. This is the magic. This is the actual part that installs what we need in order to get this to run on Intel Arc GPU, the built-in version. Okay, so this is going to take a bit to go. It's going to download everything that it needs. So I'm going to let that happen. We're going to hit pause or stop on this recording, and we're going to come right back in, and we're going to launch it. See you in a bit. Okay, it has finished installing everything. So the last thing is this command in order to launch. And let me just get back to the bottom of this. Type that in, and we'll let this go. Takes a little bit the very first time, but then it should get going. Starting server, and there we go. All right, there it is. So I'm going to open up a new Edge browser, put this in, and there we go. This is the default interface for ComfyUI, the default workflow. So you know I'm using the default. I can hit clear, OK, and load the default one. Now, what I have here is I've got Epic Realism already downloaded and loaded. So what you're going to want to do is download a checkpoint and put it in the ComfyUI models and checkpoints area. I have Epic Realism there. You can get all of these models from Civit AI. If you go over to filters under Civit AI, you can look for checkpoints and Stable Diffusion 1.5. And then from there, you're going to have a bevy of really cool models like Dream Shaper, Realistic Vision, Epic Realism. These are fantastic models, and I downloaded the Epic Realism one. So I'm going to go ahead and hit Q prompt. That's going to go and get this started. There it is. Now it's getting it started. And just so you can see this hit my GPU, yep, there it is. It's now hitting the compute of my GPU. and that is running. And then we are going to have an image in a matter of moments here running on um, this thing. That's right. Just so you can see, this is actually the thing that we're using. Um, it's going to be right there. And there it is. We are here. That's it. We generated this image of a galaxy inside a bottle, which was really nice. Um, that is done running on an MSI Claw, ComfyUI, but we can do better. So here I am also on a Meteor Lake system. So this is my MSI Prestige 16. So we're not on the Claw anymore. So you can see this is a little bit different here. I've got essentially nearly 16 gigs of memory on there. My GPU is getting hit, and we are producing a galaxy in a bottle just as well. But you'll notice this is happening a little faster. In fact, if we look at this here, we can see that's happening in every kind of 2.5 seconds. We are producing another image. And that's because I'm doing something called an LCM LoRA. I am still using the Epic Realism node, but I've plugged in something new here. And I'm going to walk you guys through it because if you're going to be doing this type of stuff on something like an Intel Core Ultra with built-in Intel Arc GPU, you're going to want to know the tips and tricks on how to do these things so you can get this stuff done a little bit faster. So I'm going to go ahead and pause this here. We're going to walk through what I'm doing in order to get this run at about 2.5 seconds per image compared to what we were doing before. Okay, so let's walk through this here. So obviously we have a node system here, and I'll walk you through so you know what's going on. So as we've added in the LoRa, you know how that's working in the process. So the very first node that we have, and everything that you're going to start with, whether you're doing this in Automatic 1111, ComfyUI, or something else, is you need to start with your model. And your model is usually going to be the checkpoint model. That's the core model that you're going to use to base all of your image generation on. And so I'm using the Epic Realism model that we got from Civit AI. So I've started there. Then what you would typically do is these yellow lines going to go out to these clip spaces, and these clip spaces are just text boxes, and they're used so that you can describe what you want in the scene or what you don't want. And how you define what's going to go in versus what's going to be out is through the positive or negative ties into the K sampler. So this description right here is going into the positive, therefore that's what I want. And then this one is going into the negative, which means that's what I don't want. And then down here, we have the empty latent image, and really this is just your resolution. So I've got it set at 512 by 512, which is the standard resolution for Stable Diffusion 1.5, which matches the checkpoint that we got from Civit AI. Then we have the K sampler, and the K sampler is where all of the kind of I guess data science magic happens. All of this kind of really interesting diffusion stuff where we take a very noisy image and we turn it into something that looks like a picture that we described. So there's a seed, which is really the randomization of a noise pattern. If I duplicated that seed, if I went back in my history and I replayed an existing seed, I'm going to get the exact same image that I had before. So the seed is deterministic. Random just means the next image is going to be a random seed. I can do a fixed seed, which I would always generate using the same seed. I could do increment or decrement, which means that I can either go up the seed number or down in the seed number to generate something different. Steps is how many steps is it going to go through the diffusion process in order to generate that image. Generally, the higher steps that you have, usually the higher quality you're going to have. CFG is going to really kind of say if it's a low number, then it's going to get a little bit more creative. If it's a higher number, it's going to try to adhere to your prompt a little bit more. And then sampler name and scheduler, those are really just certain models have specific sampler names and schedulers that they're going to want you to use. Now, if you remember when we did this on the MSI Claw, we had different information here. I had a higher steps and a higher CFG and a different sampler name and scheduler name. And that's because the LCM LoRa that I'm going to talk about in a moment really wants you to do fewer steps and a lower configuration in a different sampler name. So we were at 20 steps before, now we're only doing 4 steps. And we're able to do it in 5 times less steps because we've added this guy. We've added a LoRa. And a LoRa is another model. Now you can get LoRas from Civit AI as well. Typically a LoRa would be something where if I'm starting with a model, maybe it's a stable diffusion model, and I want the outcome to look a little bit more like Disney characters, or I want it to look a little bit more like a sketch, a line drawing, maybe a charcoal sketch. There could be a LoRa that's specifically trained to give that type of output. So you can add a LoRa in so that it weights the output towards that look or that feel. So that's typically how LoRas work. This is an LCM LoRa, and an LCM stands for, we'll go ahead and look at it, latent consistency models. And it's really just a new way of doing the diffusion process where you can do it in fewer steps. There's a lot of math behind it, a lot of data science behind it, but what it essentially does is it allows you to do it in fewer steps. So if you go to Hugging Face and you search for LCM LoRa, you're going to come to this page and you're going to see some models there. So you've got your Stable Diffusion 1.5, and then you have your LCM LoRa SDXL. You will download one or both of those depending upon whether or not you're working in Stable Diffusion 1.5 or SDXL. So since I'm working in Stable Diffusion 1.5, I downloaded this and I put that in the LoRa folder. So within ComfyUI, you have your models folder and then you have your LoRa's folder, and that's where that was located. So by doing that and being back in ComfyUI, and if I hit refresh here after downloading that, then that becomes available for me to choose as a LoRa. But so by simply plugging this in between where all of these lines are supposed to go, so usually the model goes directly into the K sampler. So now we put the model into the LoRa, and then we do the model out into the K sampler. Same with clip. Clip goes into here, and then clip goes out to the positive and negative clip, and then they follow along as they normally do. So that's really the basics of using a LoRa. Now, because we're using a LoRa, I changed the steps from 20 to 4, and I changed the CFG to 1. So the CFG is way more sensitive, so we have to move it from what might have been maybe between 6 and 8 all the way down to 1 to 2. And then I've set it down to 4 steps. So let's go ahead and turn this on and we'll see it run. And you can see that it's working fairly quickly here. But you'll notice if we look into this bottle here, that galaxy maybe isn't as clear or isn't as good as it was. So I'm going to up this to 8. Let's just turn it all the way up. Now it's going to take longer to do, and it may generate a slightly better looking image because we're giving it a bit more time to do. Let's see if we get a little bit better. I guess that's a little bit subjective. I'll move it down to 6 and see if that's any better or not. But that's the thing that you'll notice. If you move to LoRa's, you might have less quality. But what you can do is you can go through another refining process. You can run the K sampler again once you have an image that you like. So you may iterate on a number of images using the LCM method and then stick to that specific seed, and then run through the sampler again in order to get higher quality. So that's step 1 in using LCM LoRa's in order to improve your speed and efficiency in getting images out on your Intel Arc GPU. Okay, we're on to the next step here, and I want to demonstrate a couple of things that you can do to adjust your output from LCM in order to get it at a higher quality. So we're running essentially the same exact workflow that we had before where we were running it through a bottle. What we have is we have a checkpoint, we have the LCM LoRa, we have our text, a bit more text. For the sampler is set up exactly the same, and we're generating images. And if I look at this, we're generating images in every 5.66 seconds here. So one of the reasons it's generating a little bit longer time is if you look, one thing that is different is my empty latent image. So this is a taller image. So there are more pixels to work with in generating this image here. But this is generating images fairly nicely. But you look, at these, they're kind of soft images here, and so they're okay. But I think we can do better. But this is stable diffusion, so I had the ability to just generate a lot of different images until I get to one that I think is good. So I'm going to go down to, I think 70 here is one where I started. Yeah, here it is. So I like this pose. I like the look. We've got this nice uh, forest in the background, which is a little bit blurred out. There's some decorative information on her garments, all that kind of stuff. So I think this looks good, but I just wish it was better detail and slightly higher resolution. So by me going through my history, and I did this by clicking on view history. So hit me go to close and I click view history and I went down to number 70, which is one that I liked. So by clicking on it, what it did is it loaded all the information from that one. What I had done when the last time I ran this, it was on fixed. So I'm going to keep it to fixed, but generally it'll probably be on something else. So you'll want to make sure that it is fixed. And that way, if I rerun this again, it's going to stay on this seed. So in fact, if I hit Q prompt here, it's going to run through and it should end up looking the same. Aha, good. I was worried. But yes, now it looks the same, right? So that is all we wanted to make sure that we're done. Now I want to be able to do a few things where I can adjust this. Now, what I've done is I have kind of blocked out some other things that I've put in here. And you can essentially bypass, like if I wanted to bypass the LoRa, I would hit Control B and it would bypass the LoRa and not use it. And all of those lines would work as it normally would. So it's a nice little tip here. So a couple of things that I've added here is upscale, latent by. I've added another K sampler, a decode, and then another save image. So essentially, everything that I had at the end, I just copied and pasted. So I had those there. The new thing is upscale latent by, and you can get to this node by double clicking and just typing upscale latent by, and there you'd have it, right? So the way this works is you want to just take the output of your case sampler and put it into the upscale latent by, and then plug that into the latent image. So this empty latent image is no longer used. It's going to use the image that we have here. So it's going to base it on this. That gets plugged in here, and then all the other things that you would normally plug in here go back in. Now, if you can't remember what those were, just look at what you've got plugged in, follow those nodes, and plug in the same here, and then it'll output. Now, you could set a random seed, you could set whatever, you can try to set it the same, but what I've done here is I've got 4 steps. I've upped the CFG, and I've noticed that when I do CFG, that sometimes as I do an upscale latent by, it's a little bit more washed out. So by upping this CFG, it makes it a little bit sharper and more higher contrast. I'm changing the sampler name. Now I know I'm still using an LCM, but it's mixing these two, and that's fine. So I can mix a little bit. So I'm using Euler, Ancestral, and Keras. Now, denoise is something we didn't use because we weren't mixing anything. And usually denoise is when you are taking another image and using that as a reference for what it is that you want to output. So you would use that instead of the empty latent image when you're doing image to image. So this is essentially an image to image workflow. First, we did text to image. Now we're doing image to image. And so the mix here is 0.55. So I've got all of that done. And I am upscaling it by 1.5 times. So this is going to take longer to generate. So I'm going to get that going, and we can see that this will hit my GPU right here. So yeah, that is starting. Now, it didn't have to regenerate that image, and that's a really cool thing about ComfyUI is it knows it did everything up to this point. So it's not going to redo the stuff that it already has history on. Anything that's changed and new, it's going to do that going forward. So that'll save you time as well. Another really, really interesting and unique thing about ComfyUI. So here we go. So yes, that looks pretty close to this image, but look, way more detail here. In fact, what I can do is if I wanted to, whoops, just undo that. If I wanted to, I could do increment here, and I could run this again and see if I can get any differences, because again, this is going to have some noise pattern that it's going to integrate in with it. So with a randomly slightly different noise pattern, we might get slightly different detail in here before. Hair might be slightly different, eyes might be slightly different, etc. So you could run a number of different images like this until you get to something that you like. So let's see how this one is any different. And yeah, definitely different from there to there. Yeah, so in the first one, it had a little red ruby there. And this one, in this one, it doesn't. So again, you can run this over and over again. And again, it's only going to run it from the point that is changed. And the thing that's changed is the increment on our seed. So that's the new thing that's happening every time it's running. And therefore, it's only doing this portion forward. So there you go. That's how you do LCM. Find something that you like going through iterations, and maybe there's an image that you think is really good, but then you want it better. You want higher quality than LCM is going to give you. Use the upscale latent by, plug in a sampler, make a few modest changes, change the denoising down to around half, and then output and see what you get. Okay, so we got one more thing to do. We're going to up the game one more time, and we're going to do that on the Intel Arc A770. Okay, we're at the final stage, and we're going to up our game on using the Intel A770, and we are back in ComfyUI. And this may seem crazy. I have stuff all over the place, but it's basically what we've been doing this entire time here. So I'm showing you something else, and this is the ability to control that output. So what we saw before with ComfyUI is we were generating things like it's something in a bottle. We had like the galaxy in a bottle, and then we had the girl in that particular pose, but they were fairly random in terms of what we're trying to get on the output. But as we look at Stable Diffusion as a potential workflow, what we should be seeing is more and more control by the end user, your ability to essentially dictate what you want in this. So what I'm going to do is explain a little bit of what I got going on here. If you look at this, this is what looks like a photograph of this over here on the left. And we're using this information as controlled input for this. And this is using something called ControlNet. Now, I'm not going to go into how to install ControlNet, all of that kind of stuff. If you want, you can ask me in the comments or you can Google it. But just so that this video is not crazy long, I just want to demonstrate what I have going on here. So I'm going to pause this as it's been generating through a couple of iterations of this. So first off, what I have over here, this is the Revit application. So Revit is from Autodesk, and it's a CAD application. And so I can generate images from this essentially as a control. So this is information that's going to direct what's going to happen in ComfyUI. I'm using this node called Screen Share, which I added in. This comes from the community, so found that, grabbed it, did the install, and this allows me essentially, like any screen sharing applications, you can say what you want to share. I can share a window, I can share a web camera, or I can share a desktop or part of a desktop. And what I'm doing is I'm sharing part of this desktop. I'm sharing this area in the upper left-hand corner here. So you can see that shows what I'm sharing. And then this is being used as input. So this is essentially what I'm grabbing as I adjust this. So if I turn on live preview and I adjust this, we are going to see this information adjust here. If I zoom in, there we go. There it is. Okay, so the refresh rate is a little bit slow. So that's what it's doing. It's refreshing. I'll go ahead and stop that live view. But this information is generating a preview image. And then I have this new thing that I've added in, which is for ControlNet. So this node and the next node are key. So this first one is pre-processing it into a line format that ControlNet can use. And then I've got another node here, which is ControlNet, and it's got its own model. So I've got the Canny model, which is essentially a line net control for it. So those two nodes, the pre-processing node, as well as the model plugged into the ControlNet. And think of this like a coloring book. Essentially, I'm creating the lines that I want Stable Diffusion to fill in based upon Revit, based upon the model information, and the words that I'm using. In fact, I can change some of the words here. I can change this to rainy day, and then I've got this going here. So I'm going to run this, and it's going to generate this, and it's going to generate it based upon the word rainy day. So everything's the same. So yeah, let me go ahead and adjust this here because I think I need to look at the street a little bit more so that we get something that looks like a rainy day. So I'll adjust this to update, and it's going to go ahead and push this out. So we're seeing a little bit more street. We should see something that looks a little bit more like it's a rainy day. This does it. And there it is. Now it looks like it is raining. And I could say sunny day there. Get rid of golden hour and generate that and see what we get. So again, the prompts will also work as well as the controlled information that allows me to essentially control the output of what I'm trying to render here. And so this provides great flexibility for you. You have the power of Stable Diffusion through a node-based system like ComfyUI, where you can control it with both words and other software that you're using like Revit in order to generate an output here. Okay, there you have it. We've done quite a bit. We installed ComfyUI on a handheld gaming device of all things with less than 8 gigs of memory. And then we stayed on Intel Core Ultra, something with 16 gigs of RAM, and I showed you how to do it faster with an LCM LoRA. But we noticed that the output wasn't as good as we wanted, so I showed you how to upscale that and rerun it through the sampler so that you could get a better looking image. So you had a little bit of control of the output. And then I showed you how to do ultimate control using ControlNet, treating Stable Diffusion like a coloring book, having the right model, the right prompt, and the right controls to get the output that you wanted. So what did we learn is that you can do Stable Diffusion on Intel Arc GPUs across a spectrum of devices with a lot of control. Ah, spider, always the spider. Oh, you're still here. Well, I hope you enjoyed that. And if you did, please like the video and subscribe to our YouTube channel because that way you'll get more TechCraft videos because there are more to come. But until next time, I'm Bob Duffy. We'll catch you later. Okay, you're mine this time. I got you.